This video is brought to you by Hygromo Chalk. Use code TPSA 10% off to get a discount. Okay, so we can get on to the idea of connected sets now. So again, this kind of follows your intuition for what a connected set would look like. So we said that X in RD is connected if it cannot be expressed as the union of two subsets with neither of them being empty, their intersection being empty, so them being joint, and both of them being open in X. So for example, this here is a connected set, because if you try to partition it into two disjoint sets, here and here, these actually wouldn't be open because you'd have this in X, because you'd have this like line going through them. Then here, very easy, you can just partition into this one and this one, and both of these will be open in X. And you can kind of see why that would be true in this example. So if we took X being this union here, 0, 1 to 2, 3, well, X1 can be 0, 1, X2 can be 2, 3. X1 is very clearly open in R, so it's open in X. Now, 2, 3 is not open in R, but we can write it as this intersection here. So the open interval of 3 over 2 3 intersection with X, and that is open in R, so that means X2 is open in X, and they're clearly disjoint, so X here will be disconnected. In R, it's easy to think about connectedness because sets in R are connected if and only if they have what we call the intermediate value property or intermediate point property. So for any 2 points where in the set where X is less than Y, if we took some random Z in between the two of them, then that Z would have to be part of it. So here you can see this, if we took X as the union of these two pieces here, it's clearly disconnected because we have X and Y, X less than Y, and we have some Z in between them. That Z doesn't necessarily have to lie in the set. So in R, the only connected sets are the null set, R itself, any interval, and single elements. Now, if we look to RD, if X is connected, then its only subsets that are both open and closed are the trivial ones, which is the null set and X. If X is disconnected, then it will have other such subsets. So here we can see X, which will be the union of these two sets here, neither of which are open or closed in R. But because we can sort of put like a bubble around this one, right? Which this bubble will be open in R, and then the bubble intersection with X would give X1. That means this X1 is open in X, and the same for this one. So these would actually both be open, and we can just take the we can show that this is closed as well by just expressing it, with complements instead. And then a final note to say that if a map is continuous, then it will map a connected set to a connected set.